In this video, we're going to take a look here, at least briefly, at example number 2 and what this question's asking and how I might actually approach it. Let's take a look at what it says. Data for waist size and body fat percentage were recorded for 20 randomly selected adult males. And we want to test to see if there is a significant linear correlation between these variables. Notice that we're not trying to test to see if there's like a positive relationship or a negative relationship, but really just if there's any kind of relationship. So if I was to go ahead and start setting up my hypotheses here, I would say that my my H0 is that my population slope is 0, indicating no relationship. And my alternative hypothesis is that my population slope is just anything but 0. It's not equal to 0. If I take a look at the data that I have, I know that I'm going to have to enter this into the calculator. Now, this is where sometimes when people read lists like this, they get a little bit potentially confused about what exactly is being given here. I should notice that I'm working with, again, a sample of 20 randomly selected adult males. And so what I have here is the waist and body fat percentage for each person individually. So if I was looking here at person number 1, I can see that I have their values recorded. Person number 2 is listed over here, all the way down the line until I got to this person, which is actually person number 10 if you count it out. Now on the bottom, what I have is just a continuation of the original top list. It's just too long for it to fit all on one line. So these numbers here are for person number 11, and if I was to continue all the way down, down here is person number 20. So if I was to go ahead and enter this into the calculator, I would see that I could put like all of my waist sizes in L number 1 on the calculator. So that way this is all a part of one list. And I would put my body fat percentages in L number 2. So I should just ultimately have 2 lists in the calculator. Now this is as far as I'm going to actually go here in the video in terms of completing this question, but I'd ask you to go ahead and try to work through this question on your own and compare your answer with the results posted up in Blackboard. Now, before we end this video, I'm going to make a couple quick comments about the next problem. We're not going to do this question here, and I'll explain why. This question was originally here to help us understand how we could build a confidence interval for the slope of one of these population lines of best fit. So what we're going to actually see is that this question is going to be removed from this section for our semester. And part of the reason for that is since we're not actually face-to-face this semester, it will be too difficult for me to actually try to get you a special slope CI program if you are in possession of a TI-83 calculator. And so because of that, I don't want to disadvantage anybody that has a TI-83. So this question will ultimately be removed from the questions and the content that we'll cover this semester. Now, if we were to take a look really quickly at the formula sheet, you'll see that we've already removed a couple other sections so far. We've removed section 10.3.2 that I have listed here. We've also removed section 11.5, which would have existed down here. And now we're also getting rid of this information down here about confidence intervals. So you can just kind of imagine crossing all of that out. The rest of this box is just the information that we need to perform our hypothesis test for B1, that population slope. And I have my conditions over here, which we talked about ultimately how to meet in 11.1 through 11.3. All of this bullet pointed information here is just all of the information necessary to go ahead and create all of the different pictures like scatter diagrams and residual plots and normal probability plots that we needed to create to check these conditions appropriately. So this concludes the end of section 11.4. And of course, if you have any questions, please feel free to let me know.